This is the Haas UMC 750 Material Handling Cart Optimization Project. I'm Mason Garcia.
I'm Greg Gunyon.
And I'm Juan Pablo Quiñones. To give you a little bit of a background, how we got our project, we approached one of our professors, Dan Waldorf, and he had a contact at Haas Automation who gave us a few ideas on what we can work on, and we chose to focus on the UMC 750 assembly process.
Here's an agenda for our presentation. First, we'll go over a background of our project. Then we'll look at a current process overview. We'll look at our design strategy, methodology, and results, and we'll finish with a conclusion. Here's the machine that we worked with. It's the UMC 750. It's a vertical milling machine, and the focus of our project was on the highlighted area here, which is the spindle head assembly. For the background on our project, our primary focus was the optimization of transportation carts used at the machine cast assembly station. In this station, the spindle head casting is mounted onto the spindle drive assembly using an overhead gantry crane. This process exerts unnecessary energy and consumes excessive time that could be used on increasing throughput or working on other tasks. For the current process, the spindle head casting must be mounted onto the spindle drive assembly. The picture on the left shows the casting, and the picture on the right shows the drive assembly on the carts that they arrive at the station at. An overhead gantry crane is used to move the casting. This process requires unnecessary effort and time to lift, align, and secure casting to the spindle motor. For this process, employees must bend or squat uncomfortably to secure the casting bolts, as seen in the picture on the left. The assembly is then moved to a pallet in the picture on the right to await transportation to the next station. The spindle head alone weighs over 500 pounds, and the whole assembly weighs over 1,000, so moving it with the crane can be hazardous.
This is the problem. The spindle drive assembly cart has the ability to rotate 180 degrees, but this function is not utilized in the current process. This is not utilized because the assembly process happens vertically with a gantry crane and not horizontally with the cart's mating. There are no hard stops to prevent the part from flipping and damaging the part or injuring the employee. Also, employees would have to bend over uncomfortably if this function was utilized, putting unnecessary strain on their back. This is the methodology used in order to design the new casting carts. A tape measure was used to take basic measurements of the carts and castings. This was because one of the carts did not have an engineering drawing and to get an overall idea of the dimensions of the castings themselves. SolidWorks was used to model the current state design of the spindle drive assembly cart, the new designs for the spindle drive assembly and the spindle head, and to test loads and moments. When designing the new carts, ergonomics was kept in mind. The new cart fixtures needed to be designed based on the average waist height of employees. This is because the area between where the elbows bend and the waist is the center of the preferred work zone, which is within the best work zone or power zone. These zones defined the best area in relation to the body for employees to perform physical labor. Work needs to be optimized at these zones. The carts need to be designed to minimize bending at the back and focus on bending at the knees. Lifting from the carts needs to be minimized from 51 pounds or less, just like the green area in the picture to the right. Given those design constraints, this is our proposed solution. The cart be raised 10 inches. This includes raising the pivot point, which would drastically reduce the amount of bending the employee bends over with their back. Hard stops should be added in order to prevent the spindle drive assembly from over-rotating and damaging the parts, casting, or employee. The new carts should be reduced in size. This results in less material used, which means reduced costs and an increase in space at the assembly workstation. Lastly, have the two carts mate to allow for horizontal assembly on the ground. This eliminates the use of a gantry crane and vertical assembly.
After analyzing the basic measurements from the current transportation carts, our team designed a SolidWorks model to then apply our proposed solutions. As you can see in the image, our first change was to create a hard stop that would allow the part to only rotate 90 degrees and prevent over-rotation. Secondly, to obtain the desired mating of both carts, we needed to have both components at the same height. So we increased the height of the rotating axis of the spindle drive assembly with the middle vertical steel tube. This change led us to also eliminate the horizontal steel tube that the cart had in the front because it was blocking the entrance of the spindle head casting cart. After making both changes, we realized that we could also decrease the overall size of the bottom frame, reducing cost of manufacturing and increasing workstation space. Lastly, raising the height of the rotating axis allowed us to place the rotating handle in a more ergonomic place. In the second SOLIDWORKS model, our team decided to make 3 important changes. Before, the spindle head component was raised a small amount with the steel blocks in order to have it at a comfortable position for the operators to work. Instead, we replaced the blocks for rubber pads that will be permanent components of the cart. These pads will not only raise the spindle head at a desired height, but will also prevent any undesired friction. Secondly, we added 2 openings on the back of the cart to allow the placement of screw-in bolts used for mounting the spindle head casting. Lastly, we added side supports to keep the casting in place and prevent the part from falling. In conclusion, our team learned about ergonomics and how to apply these fundamentals to material handling processes. With this new design, our Haas automation will be able to use a mating process and minimize their use of an overhead crane, reducing processing time during the assembly of the UMC 750 spindle motor. Thank you for your time, and we look forward to any questions you have.